Unit 5 is going to cover transformations on the coordinate plane. Our first lesson, Chapter 2, Lesson 1, is on translations. Our standard is Missouri.8.gm.8.3, where I will be able to describe the effects of translations on two-dimensional figures using coordinates. Our learning target is to translate figures in the coordinate plane. Your success criteria. I can identify a translation. I can find the coordinates of a translated figure. I can use coordinates to translate a figure. Let's go ahead and begin. The first thought to talk about is that a transformation changes a figure into another figure. So it's some sort of change. We are going to learn 4 possible changes in the lessons to come. The new figure, so after we do the transformation, the new figure is called the image. Our first transformation. A translation is a transformation in which a figure slides but does not turn. Every point of the figure moves the same distance and the same direction. Over here on the right, we have a red and a blue figure. If I take the red figure and move it over, you'll see that the outline fits on top of the new one. And that's the idea of a translation. I am just taking the shape and sliding it over to its new location. Remember, the new shape is called the image of the figure. And to add to this, the first one, the original, is called the pre-image. Our first example of what we're doing is just, can you tell if two shapes are a translation of each other? So example 1, identifying a translation. Tell whether the blue figure is a translation of the red figure. We want to know, to go from the red to the blue, are we just sliding the image? So take, for instance, the red outline. If I slide it left and down, it just fits directly on top of the other shape. This means to go from red to blue, all you have to do is slide. Therefore, yes, this is a translation. All I had to do was take the original and slide it over to the new one. Let's check out B. To go from the red to the blue one is the only thing I have to do where I have to slide the picture over. Well, if I slide the rectangle, is there any way I can slide this in order for it to fit? The only way for the red to turn into the blue in this case is to turn it. So no, this is not a translation. We'll learn another name for that. In fact, just for a look ahead, this would be called a rotation. That'll be our third lesson. Using these two as an example, what I would like you to do is there are two more transformations below. You're going to decide whether or not they are a translation and state why. You'll pause the video and then start it back up to check your answers. Pause the video in 3, 2, 1. To go through what the answers are, again, if I take this red one and I slide it over, is there any way that I can slide this so that it fits on top of the blue one exactly? No, there is not. And the reason for it is it expanded or it grew. It did not slide, it expanded. We'll talk about what that transformation is by the fifth lesson. For 2, if I take the red one and slide it over, I can see that it fits exactly to the blue one, which is an indication that this is just a slide. So yes, it is a translation. So that's our first portion. We are just looking at whether or not it is a translation. We're going to go ahead and move into now how do we use coordinates for a translation, as well as can we perform a translation on the coordinate plane. Key idea: translations on the coordinate plane. To translate a figure A units horizontally and B units vertically in a coordinate plane, add A to the x coordinate and B to the y coordinate. Let's talk about that for a moment. We have a graph over on the right. And in it, just to make it clear, red is the pre-image and blue here is the image. And the reason why we know that is because of this symbol. It says A with a little tick mark on it called A prime. What we're focused on is how did we get from point A to point A prime? Well, the point has to slide horizontally and vertically. Horizontally would be to the right. So we're going to the right A unit. And then going down B unit. We were told that there is a way we can just do this by adding values to our coordinates. And we have notation for this. This is called translation notation. If I start with this x comma y, or x comma y, I can perform a transformation shown by this arrow, and specifically it'll be a translation where I have my x and I add my a value to it because that was horizontal like all x values. And then I have my y where I add b, our vertical, because y represents verticals. This notation tells us on a graph how far to move the point. It also gives us a way of identifying what the new coordinates are without the need of a graph. So that's part of why we do this. We don't always need a graph to figure this out. Something I want us to take note of, in order for us to know whether we did this correctly or not, in a translation, the original figure and its image are the same. We will eventually do a lesson on what it means to be congruent, but that is the word used to describe that these two are the same. Let's take a look now at how we handle the coordinate plane. I'm going to show you two methods. Both of these methods are designed to create the image as well as provide the new coordinates for the image. So two strategies on how to do this. Here it states to translate the red triangle 3 units to the right and 3 units down. What are the coordinates of the image? For our first method, we're going to do this by counting the spaces. We're going to count out the translation. And be careful. You must do this for all of the points. Every point moves the same distance in the same direction. We're going to start by putting our pencil on A and count 1, 2, 3 spaces to the right. And then from there, 1, 2, 3 spaces down. And wherever I land, I put a new point. And we call that A prime. So A with a little tick mark on it. They want us to list out what the coordinates are, so let's do that. A prime's location is at 1, -2. Let's try B. I take my point B and I go 1, 2, 3 to the right and 1, 2, 3 down. And wherever I land, I put a point. And I call that B prime. Its location on the graph is at 5, 2. We almost have our triangle, but we have to move all 3 points. So picking up C, it's 1, 2, 3 to the right, and 1, 2, 3 down. And I put C prime in its location. C prime is at 4, -1. And for the last step, make sure we connect the dots. Now, there's a lot of pieces going on this graph. Let me pull out of the way my counting arrows. Again, these are the arrows I use to count the spaces. I'm moving them out of the way so you can see just the 2 triangles. Are they the same? They are exactly the same. So we have our solution. We have the image on the graph as well as the new coordinates. If you like this method, that is awesome. I'm going to go ahead and show a second method. You are responsible for understanding both. But if you're just asked what the new coordinates are, you can use any method you want to find that answer. So method 2. In method 2, we are still trying to do the same problem, where they told us to count to the right 3 and down 3. Now, something to think about is whenever you are counting to the right on a graph, your numbers are getting bigger. In fact, they are getting more positive. So when I said earlier we add the horizontal value, means we add 3 to the x coordinate. For the y coordinate, it tells me that I'm counting down 3. And when you count down, you get smaller. You get more negative. So we end up adding -3, or you could look at it as subtracting 3 from the y coordinate. If I'm going up, I would add. If I'm going to the right, I would add. If I'm going down, I would subtract. And if I'm going to the left, I would subtract. And this could help you keep in mind those directions. So let's find them. We'll start with A prime. For A prime, I take the -2, but then I add 3. As it told me, add it to the x coordinate. I take the y coordinate, which is 1, and since it was -3, I'm adding a negative, or I'm just subtracting 3 from the y value. -2 plus 3 is -1. 1 minus 3 is -2. Now, is that the same as our previous result? I realize I said a mistake. That mistake is here with the 1. It should have been positive. But now I can place that on the graph. At 1, -2, this would be A prime. Go to B prime. To the x coordinate, I need to add 3. To the y coordinate, I need to subtract 3. My new x value becomes 5. And my new y value becomes 2. Is that the same? In fact, it is. So I can go to the graph and place a point at 5, 2. By the end of this, we're going to have the same picture as the first method. This is just to give people another option for how to find the solution. So C prime. To the x value, I will add 3. To the y value, I will subtract 3. So for C prime, one plus 3 is 4. And 2 minus 3 is -1. The exact same result as we got in the previous problem. And now I can go ahead and graph it. Here it's the prime, and here are our identical triangles. So here is how we actually perform translations on a graph. The idea is we're trying to find the new coordinates. We're trying to figure out where one thing starts and then it ends. Go back, rewatch any part of this that you need, and try out the practice that goes along with this lesson.